This is TechSNAP, episode 386. Hi, everyone, and welcome to TechSNAP, Jupiter Broadcasting's weekly systems network and administration podcast. We recorded this episode on October 4th, 2018. My name is Chris, and joining me every single week is my co-host, the admin, the presenter, and the mathematician. Believe me, it's Mr. Payne. Hello, Wes.
Hello, Chris.
Wes, we've got a particularly special episode this week of the TechSNAP program. We're going to focus in on Google Cloud. This show really hasn't given it much of attention. It's sort of been underrepresented on the TechSNAP podcast. We talk a lot about AWS, the cloud in general, and of course orchestration tools to manage all of that, but we've never really given much attention to the Google Cloud platform. And this week we're going to bring on a Google Cloud expert and maybe change some minds about the platform and clear up some questions that Wes and I have. But before we get there, Mr. Payne, let's start with a very interesting story that relates to Google Cloud. It starts with web encryption, and when it comes to that, a surprising number of errors actually stem from a straightforward and seemingly basic mechanism: timekeeping.
Yeah, you probably don't think that much about it, Chris. Your watch, your phone, everything's connected by the internet, and they kind of just sync without you having to worry about it. And for us slow humans on our time scales, that's really just good enough. But the internet's decentralized nature means that the clocks behind all those servers, powering all of your favorite things on the web, well, they can actually have major discrepancies. I don't know if you remember from those days where you were admitting the servers, but NTP problems, out-of-sync servers, it's a common problem.
It affects all kinds of systems, and it can really derail a Microsoft Active Directory network as well. So it's not just SSL and HTTPS, it's all kinds of network functions. And really, it's a big issue in production as well. It's a problem where when machines that are all involved in a recording, say 3 or 4 systems, and they don't have the same clock, you have all kinds of sync issues when you sit down to edit. And that problem gets exponentially worse when you get to sophisticated communications over the internet.
Well, this week, Cloudflare is taking a big step to try to address some of those issues, and they're doing that by adding support for a free timekeeping protocol known as Roughtime, which helps synchronize the internet's clocks and validate timestamps. Now, this isn't just solving an academic problem. According to Cloudflare's CEO, a big reason a number of their encrypted sessions fail to get set up properly is because one of the parties involved has some clock skew. And a recent study from Google found that 6.7% of digital clocks in a random user sample were more than 24 hours behind.
Not just that, but some, 0.05%, were more than 24 hours ahead.
All of this skew prompted Google to develop Roughtime way back in 2016, and they maintain a Roughtime server to this day.
Are you roughly telling me right now that Google has invented its own time? Roughly?
Yes, I am. And it's kind of special. We already have NTP, the Network Time Protocol, which aims for precise synchronization and even accounts for things like network latency. However, well, it just wasn't designed with security in mind. That's where Roughtime comes in, and it actually aims for less accuracy, right? So the whole idea here is that it's the rough time, because for most applications, especially some cryptographic operations, you don't need the precise time, you just need the rough time.
Ah, I like the name then, that's great.
The other major difference with Roughtime is that it's had security designed from the get-go. An example of this is that a Roughtime server actually signs its response to a time request. That means later on, you can prove if they're lying. So if you do have a misbehaving Roughtime server someone's maliciously trying to mess with people's clocks, well, if you're checking multiple time servers, you'll see that they're one of the only ones that are off, and you'll have proof that they did it.
Yeah, it seems that Roughtime is designed to allow multiple Roughtime signers to be cross-checked against each other in a way that is cryptographically provable.
Yeah, and that's actually why it's been big news that Cloudflare's adopting it. So far, Google's been the only major company using Roughtime, and that makes some of those security principles we just talked about less valuable. Now there's another benchmark that we have. You can use multiple Roughtime servers. I'll also note that Cloudflare says they're not just doing this for their own customers. They want to help spur Roughtime adoption worldwide. So maybe this is the first of many to come.
Well, thank you for the explanation, sir. With all stories like this, we'll keep an eye out and see where it goes. While we're on the Google Cloud theme, though, let's talk about a new security feature that's coming. All container images built using Cloud Build, Google's fully managed continuous integration and deployment platform, will now be automatically scanned for OS package vulnerabilities. The container registry vulnerability scanning feature is currently in beta, though.
So if you are using this system and you've enabled the Container Analysis API, your images will be scanned for vulnerabilities once they've been pushed to the container registry. This is also integrated with binary authorization, which is a deploy time security control that ensures only trusted container images are automatically deployed by the Kubernetes engine.
The new feature should help prevent the deployment of vulnerable images, and Google says it should reduce the time spent dealing with security issues and downtime in general from this.
This seems nice. It's adding more controls to make sure that only blessed images that really should go out into production, make it there. And it hopefully makes auditing down the road, proving things to compliance organizations, or just, having more trust in your infrastructure.
Well, it seems like forever ago, but this reminds us, was it mid-June when we found out that there was malicious code in some Docker Hub images? It might not have been anything more than Monero miners, I don't remember now. But it was a warning flag that even though the community had been trying to raise attention to this issue for months and months and months before it went public, it was, I think, 5 images were up in Docker Hub for a while. And some of them actually had gotten deployed. And for business customers, this gives them somewhat of peace of mind when they're deploying containers on Google's cloud platform now.
If the other cloud providers aren't already providing this service, seems like they will want to pretty soon.
Well, I think I'm sufficiently warmed up now, Wes. How are you feeling?
Hot and ready to go.
All right, I know we both have questions about Google Cloud, and I think maybe we even have some skeptics in the audience. Let's bring on our Google Cloud Platform expert. So joining us now is Matt Ulason. He is one of Linux Academy's Google Cloud training architects, and he's really going to help us figure all of this out. So Matt, welcome to the show, and let's start with what really makes Google Cloud competitive over, say, AWS or Azure.
They have a lot of similarities between the three of them. I think if you want to look at specific, make the difference edge things there, it kind of comes down to a few things. Number one is things that makes Google Cloud unique. One of the big ones in that AWS is just now starting to catch up on is a global fiber network. What I mean by that is that if you have a VPC, same kind of a virtual network on AWS, but if you have one in different regions, say US Central, East Asia, Europe, all three of those networks can actually communicate on the same private network that doesn't actually have to touch the public internet between those different zones. Until just recently, when AWS announced it, I think last fall, it was the only cloud provider that by default out of the box had true private global networking over, I think the RFC standards like 1918 or something like that. Anyway, it's a techie talk for basically meaning that out of the box, you can have worldwide resources that all operate on Google's private network that never touches the public internet. So it's kind of like from a networking and engineering perspective, that's a really big one right there.
Yeah, that is going to be
impressive.
That's a tough one to catch up to as well. That's a hard one. All right. So one of the things that I've heard of that sounds like magic to me, and it doesn't even seem like Google's MO, but I know that they support hybrid environments, but they also support doing some kind of live migration where you migrate your on-premises enterprise systems up to Google Cloud and things, for the most part, stay online. How is this magic possible? What's Google doing here?
Now, when you talk about live migration, there's actually kind of two avenues with that, depending on what the context is. One is that where they, I think, partnered or acquired a company called Velostrada, where for a hybrid migration, essentially what it does is that it moves the compute and the storage, essentially decouples it from your server and kind of does it in stages. And how it works is that they'll basically have, the compute set up on the cloud side. And while it is running on both, it'll run as if it's your on-premises server while in the process of migrating your data from your on-premises server over to the new one. It is kind of some voodoo stuff, but it basically sets up a compute source on both the Google Cloud side and using your existing one while transferring the data at the same time, and both machines essentially operating from that transferred data. So it's moving and being used at the same time.
And how are they like doing that behind the scenes? Is there somebody manually pulling the levers on DNS stuff? Like that seems like a massively multi-stage project. Even to a certain point, like you have to make sure that everything's been fully migrated and verify all of the data's been moved. Even that part seems complicated.
Yep. So Velostrada is officially a Google company now, and basically Google is using Velostrada for that live migration process.
Aha. Okay. So they sort of bought the magic. I see.
The other big one that's kind of a big deal when we talk about live migration is one that's been around for a while, and it's more of a maintenance procedure. So when you have a virtual machine on a compute engine, it's on a physical server of some sort somewhere in the data center. All computers need to have, maintenance or stuff will go wrong. Some sort of patch Tuesday comes up every once in a while where you have to shut that server down to, run updates on it, like, all backbone computers do. How live migrations work is that they will migrate your virtual machine off the physical location it's at over to a different location while the machine is still running without any downtime.
That's still very impressive, and it makes you kind of want to just play around with it a little bit.
Yeah, I just want to watch it happen.
I want to see that because I remember when I was proud for getting that accomplished on a LAN between two VMs with a shared storage on the same network, and I was proud to do that.
Yep, and that's just a default option too. So you click on create an instance and then create, and the live migration option is automatically enabled. You have to purposely go in and turn it off. And there's a few scenarios where if you want like a physical drive attached to it, which is a rare case, you can't use that. But for the most part, it's like, that's just the default. Those crazy magic high-tech things is just how it works out of the box without you having to think about it.
One thing I've seen a lot of other cloud companies start to advance in is IoT technologies, or wanting to be the data warehouse and the analytics platform for people collecting a lot of IoT data. I did see some talk about some IoT simulators with sample data that Google Cloud has. How does that work? Why would I use Google Cloud for IoT?
From the IoT perspective, just by itself, I think Google Cloud and Azure and AWS all do, a perfectly fine job with that. And they're all coming out with their own services that specifically are designed to manage IoT things out there. Kind of talking about the whole simulation perspective is, if you want to explore it, unless you have a bunch of physical things sitting around to hook up to the internet, it's kind of hard to practice because, you have to invest in a whole bunch of physical things. Some of the simulations they have out there is it'll let you take simulated data from a bunch of maybe like weather locations all around Europe or all around the world, where you can take the data that's generated by quote unquote things, even though it's not, and let you set up the rest of the processes, the other services that let you absorb that data, ingest it, process it, stick it in some sort of a data warehouse for, get some sort of like business insights and stuff from. The simulated applications is what lets you use the other unique Google Cloud services to be able to see how they work and essentially kind of let you test drive it with simulated data to see if it's something you may want to work with actual live data down the road.
So the simulated data isn't just for IoT device type creations, but you can use simulated data for other areas of Google Cloud?
Oh, yeah. So in the IoT example specifically, it's basically used for, they give you the simulated data to ingest, but then what you would do after that in, I think, this particular application we're talking about, you can basically use a cloud service called PubSub, which is equivalent to Kinesis, I believe, on the AWS side for your real-time messaging. You can run it through a processing pipeline through Cloud Dataflow, which is built on Apache Beam, which can then export it over into BigQuery, which is serverless data warehousing, all the unique Google Cloud services. So you have like an entire processing pipeline in which you can take the simulated data, ingest it, process it, and then push it over to some sort of an analytics solution that you can do further analysis on via SQL queries or whatever else.
And it's not just building out the pipeline, but it's also then being able to test that pipeline under stress. You can throw a lot of data at it and get some real results so you know what it's going to be like when it has customers on it.
Oh, yeah, definitely. Really, the big thing in cloud these days, not just Google Cloud, but the other ones in general, is the whole scalability aspect. One thing, there's kind of the either like the pithy or snarky saying about, cloud computing is just using someone else's computer. I'm sure you've seen like little bumper stickers like that. But okay, you're using somebody else's computer, but their computer is a heck of a lot better than your computer.
It sure is.
Yeah, and what I mean by that is like, oh, you're just using someone else's computer. Okay, well, that one computer can scale out to thousands of computer as your application grows. So that way, it's not just a single computer, but you're literally leveraging like entire data centers worth of computers for basically peanuts.
And their fiber network in some cases.
Yeah, so it's like it's someone else's computer, but their computers can basically multiply themselves, and their computers and network is a heck of a lot better than yours. And to do something what you can do on the cloud by yourself would cost you like bajillions of dollars, basically.
Okay, well, speaking about scalability, another service a cloud provider would not be caught without is Kubernetes.
Correct.
I keep hearing that Google Cloud's implementation is just simply the best. Do you agree? And if so, what makes it so good?
It kind of makes sense because Google's the one who invented Kubernetes. I mean, they used it internally for most of their services before releasing it to the public. So they already had like a multi-year head start because it was their own internal project before it became available to anyone else. So it's kind of like how AWS had kind of the cloud advantage because they were first to market. Google was literally first to market with Kubernetes because, they had
the Borg
baked internally for years. Yeah. So it's kind of one of those deals is like, I know other cloud providers are releasing their own Kubernetes solutions. Amazon has, I believe it's called EKS, right. Elastic Kubernetes. I forget what it stands for. But it's kind of one of those deals where you're going to the source for it. So they already naturally have a huge head start on that.
So Matt, you do a Google Cloud Weekly update on the Linux Academy's YouTube channel, Linux Academy.com. And so you're following the developments of the Google Cloud platform very closely. And I'd be kind of interested to know where you think Google could be more competitive, where maybe AWS or Azure has them beat right now.
That's actually a really good question. In fact, one of my colleagues actually pointed out someone asked it on, what's it called, Quora? I think someone who asked that very same question that I went ahead and answered. There's really kind of three main things there. Number one, on AWS's side, they had a multi-year head start for a public cloud. So it's kind of one of those first mover advantages. So at least from the AWS side, they were first to market. Also, when AWS and Google Cloud both had public clouds available, AWS was more willing to meet enterprises where they were. And Google was kind of more like, hey, here's where the future of tech is going. This is what you need to be doing instead. So, for example, Google's Cloud's first public product was App Engine, the scale your code up, serverless, and all that before serverless was cool.
Right.
Enterprises, though, are like, we want virtual machines. Google's like, no, this is the future isn't virtual machines. The future is something like App Engine and serverless computing. Meanwhile, AWS is like, you want virtual machines? Here's your virtual machines for you. So it's kind of one of those things where I'm fully believe from an engineering and kind of future forward perspective, Google's way on top, but AWS did a much, much better job at meeting the market where they were at as opposed to where they thought it should be going.
Yeah, that makes a lot of sense. I don't think I would have been able to put that into words myself, but it seems pretty understandable. And it seems in there that there is the implied statement that if you're willing to modernize or make a long bet, Google Cloud is really worth a hard look.
Mm-hmm. And when you start to get to where different cloud platforms kind of diverge, when you start getting into some of those more forward-thinking perspectives like serverless data warehousing. So, for example, BigQuery is Google's data warehousing product. It's actually completely serverless. So you put petabytes of data into BigQuery, and there's no machines for you to actually manage. I believe AWS has a data warehousing solution, but there are actual machines that you have to manage of some sort. So it's a little bit different model with that.
I noticed, too, in one of your weekly updates that Google is now implementing like a hardware-level encryption as a service for customers that are extremely paranoid about the data. Not only can they have control of the encryption key of their data, but now there's a hardware solution, too. That's a pretty big commitment.
Yeah, I think this is one of the situations where Google is actually catching up with Amazon because they've had it for a while.
Yeah.
I believe it is, I don't have the acronym in front of me right now, but yeah, so both products have software-based encryption service where you can manage encryption keys on their platform. You can store them on there, cycle them out and stuff like that. But those are all essentially software encryption. Right. Some of the really, really high-end compliance requirements is like FIPS something or other. That actually requires a hardware module, like a physical hardware module for creating those encryption keys, which basically mean that unless you have access to that same physical piece of hardware, you can't decrypt it. So it's kind of like next level stuff. So Google is, and AWS, and I'm sure Azure is as well, offering like your own unique hardware encryption module for creating those really insanely high compliance standard keys.
It's just fascinating to me because it takes the whole data angle out of it. It's not about collecting data in this case. And that seems like that's probably something that some people listening might be a little skeptical about.
Right. It's different than how Google's most of the rest of their business seems to operate.
So funny you mentioned that. I think the funny thing when it kind of comes to technology is that people tend to understand a small slice of what they're used to, especially on the consumer end. And that doesn't apply just Google, but also Apple, Amazon, Microsoft, stuff like that. If you ask like the average person, what they knew about Amazon's cloud platform, AWS, the only thing they'd probably be aware of is like Amazon.com, or I have Amazon Prime. That's kind of the cloud, right? Which technically it is, but it goes so much deeper than that. So going from the Google side, if you look at like a free Google account, Gmail, Google Drive, whatever, there's no secret that Google offers those for free, or at least, pretty cheap if you use the paid plans, that they use your data for advertising. I mean, they're very upfront like that. And that spooks some people, which is fine as well. The thing is, though, is that once you're getting into more the cloud platforms like AWS, Azure, Google Cloud, etc., those are completely different beasts compared to the consumer-facing products. And that, yeah, it's the same tech company using those, but that's pretty much where the similarities end. So this kind of comes to if someone asks me like what I know about accounting, I'm not going to know hardly anything because I'm not familiar with that, or doctor, whatever else. So it's kind of hard to talk about it without sounding like you're high and mighty and stuff, but it just kind of comes down to lack of actual knowledge about, how is Google Cloud different from Google Drive, or how is AWS or Azure different from Office 365 or Amazon Prime and stuff like that.
G apps versus Google Cloud and things like that.
Yeah, or even G Suite versus like the free Google accounts, which is it's the same products, but with G Suite, those are organizations paying money for that, and all the privacy and compliance considerations are completely different as well.
Yeah,
when you use a business G Suite subscription, Google does not collect data. Period. I mean, they go through like a bajillion third-party audits. Their biggest competitor in that is Microsoft with Office 365 for Business. So while, the consumer side free model, they're collecting advertising. If you're paying for the product like you are for a business, then they're not collecting data because they're attracting businesses who have strict privacy and compliance requirements. Same company, very different models. And that's true for both Google, Microsoft, Amazon. I think Apple tends to be privacy focused regardless. But across all the different tech companies, it's the same company, but depending on the actual product, when it comes to privacy and security and compliance standards and privacy standards, very, very different animals.
Yeah, that's the game they have to play if they want to serve those customers. They don't really have a choice. So
yeah,
that's how it is. That's the game. Well, Matt, thank you for coming on here and chatting about Google Cloud with us. It helped me understand a few things that I had heard about, that the things that you hear out there, you read out there, and you want a little clarification. I'll have a link to Matt's Twitter profile in the show notes, techsnap.systems/386. If you want to chat Google Cloud with him, you can tweet him there, or go check out some of Matt's courses on the Linux Academy platform. You go over there and learn all about it. And we'll also have a link to one of his recent Google Cloud weekly updates on the YouTube channel. Matt, thanks for coming on the show.
Thank you very much. Appreciate it.
Thanks for visiting techsnap.systems/contact for sending in your questions, your follow-up, or your war stories. And Mr. Rodriguez writes in this week with a question for Mr. Wes.
Here's my problem. I would like to connect from the internet, maybe from a company website, somewhere external to my main network, back to my main network directly without opening ports and without using a VPN. That way, when I'm not at home, I just first connect to a server somewhere on the public internet, and from there, I can connect to the home computer. But, crucially, after this first connection, I don't want data to travel through that proxy server. I'd like to make a direct connection back to my home network.
So he's looking to communicate with systems behind a router using NAT without opening any ports on that router or firewall to allow an external connection in.
Yeah, it sounds like once that connection's made, he'd like to do something like be able to just browse files that might have been hosted on a server in that home network, or maybe connect to an own cloud instance. Now, there's probably a lot of different technologies that could come into play in a scenario like that. The first one that came to my mind, while it is a VPN, it's a little bit different. That's Tink, which bills itself as a mesh VPN. And if you get it set up correctly, you can have a three-party system where one machine is just out there on the public internet. It can facilitate setup between two peers who then communicate directly once they've established a connection.
This is also how services like TeamViewer or Simple Help or many other remote login services work, where there's an intermediary proxy or server that establishes the connection on your behalf and then often makes it point-to-point after that.
Those technologies usually rely on something called ICE, or the underlying technologies stun and turn, which are ways for a server behind a NAT to find its address and then use that public server to facilitate busting through the NAT, establishing a persistent connection, the data that can then flow both ways. So you may need to set something up if you have a particular service that doesn't implement this for you. You might have to roll it yourself.
Bob, who's also a longtime listener, and I think he particularly appreciated the Wimpy episode, writes in with a bit of a war story. He says it dates way back, about 15 years. At that time, I was just an IT apprentice. Every so often, some computers were losing connection to the LAN and to the internet. Sometimes just a few computers. Sometimes it was one part of the building, at different times of day, at different times in the week. Never the same. Sometimes for a minute, sometimes for 15 minutes, even an hour. And it was always different. There was no common point to these outages. Or was it, he says. We run all sorts of diagnostic programs, tried to determine why computers were losing connection. We also brought some Linux machines on just to test if there was a problem with Windows specifically. But also Linux had the issue with these connections. We also ran diagnostic programs on Linux that were specific to that machine, and we got no useful results. It took about half a year or even more, I don't really exactly recall, to point the common point out to all of these outages. It all came back to a switch in the conference room.
No way. Oh, that's crazy.
During rapid growth of the company bought offices next door and expanded the LAN into that part of the same building. And things were moving fast, and the IT guys didn't have time to plan and prepare network growth, so they bolted a switch under the table in the conference room with a plan to reposition it later to a more suitable place, but later never came, and it stayed there. Every time a particular group of employees had a meeting in that conference room, a guy sat at that table, and when he got bored at the meeting, he started to play with the cables. He unplugged them and replugged them into different ports, pressing all of the buttons on the switch, including the power button. But after the meeting, he managed to put everything back in the right place and turn on the right buttons. Simply amazing, he says. One of the reasons it took us so long to track this down was because there was always a meeting in the conference room, so we couldn't go inside and check the switch. And after the meetings, everything was okay, so we figured that switch must be fine.
It all comes down to an ignorant user and, of course, technical debt.
Yeah, he writes, after this incident, we did find the time to reposition the switch to a more suitable place. Also, the employee was repositioned to a more suitable place. Thanks for the great show. Best regards, Bob.
Our last email for the day comes from a new sysadmin and longtime listener.
Longtime listener trifecta.
I've convinced my boss to let me move some of our tooling over to open source alternatives. And so far, we've both been very happy with it. However, I've quickly came to the realization that if I want to make sure everything stays in this wonderful condition, I'm going to need some monitoring. So far, I've set up Netstat and Prometheus, looking to pair it with Grafana sometime soon. That's where it gets to my question. I'm looking to monitor the health of external services and then eventually display it on that Grafana dashboard. So things like Slack or AWS.
So he wants to bring in outside services into his existing metrics.
Right. So maybe you quickly see things like, oh, the thing we integrate with, that's down. So of course our system's going to have problems.
Right. More and more important, too, as you depend on more and more services. There's things that run through Slack for companies, certain types of notifications or kickoff scripts that get started, or when a Git process is completed, it notifies Slack, which then sets off a chain of events. It's critical to track that stuff because at the end of the business day, it's generally the people in IT that are responsible for things working, regardless if it's an external dependency or not.
Exactly. Now, the first place to look, I guess, would be external services. I've used Site 24/7 in the past, but there's a bunch of competitors.
Yeah, I've used Pingdom before.
And they specialize in, right there in the name, pinging, checking URL endpoints, scanning things to see if they're online, and you can set various thresholds and configure them.
They'll do things like load a web page and see if a particular thing is there, pulls down the HTTP headers and make sure the server's actually responding.
Yeah, basically a hosted curl and grep that has a lot of nice features built right into it.
But really, to get the level of detail that he's going to want, he almost needs them to have an API, really, to check in with.
That would make it a lot easier. Now, if you're stuck doing some screen scraping, that can work. Might be enough to do, just a broken switch on-off. Is it broken or not? But if you want that fine-grained, like, it's warning if these services are broken, but it's critical if this subset or something, either that's a lot of screen scraping or hope that they have an API. AWS has their health API that can let you know about events that might impact particular sections of your infrastructure. So that's one place to look. I would think that just about any monitoring system, certainly Nagios can do this, where you just configure it to check a URL. You can set things like cookies or authentication that it can use. In particular, you might try the Prometheus Black Box Exporter, which can be configured to check HTTP endpoints, look at status codes, and look for content.
Good luck, new sysadmin. You can send us your questions, your war stories, your feedback, techsnap.systems/contact.
Well, that brings us to the end of this week's program.
Thanks so much for tuning in. We have a few final thoughts and some follow-ups. Number one, I'll give a shout out to Will Boyd. His Kubernetes the Hard Way, I believe, is getting released early. In fact, as we record, I believe it's out now or it's out in the next couple of days. So if you liked our chat with Will Boyd and you want to go in deeper, go check that out. And on the topic of Kubernetes, we do have a couple of follow-up items for you, including one that I thought was pretty neat. How do Kubernetes deployments work from an adversarial perspective? And this one I like because it looks at the different areas that could get broken in a large Kubernetes setup and how everything responds after that, what begins to fail.
And it relies on a neat new tool called KubeSpy, which gives you an inside look at what's happening as all those complicated Kubernetes actions actually happen. Now, of course, if we're talking about Kubernetes, one of the biggest debates is, should I be using it at all? Here's one post that argues it's a surprisingly affordable platform for personal projects.
Yeah, that was an interesting, detailed post, although I also caught this one. Is Kubernetes for personal projects? No thanks. And it was a rebuttal to that post that calls out all of the areas that complexity make it just sort of a bad idea for small personal projects. However, I think the rebuttal misses the point of the original author in that the original author was trying to show you could do it at a affordable price for personal projects. Not that you would want the complexity, but that you could actually do it for around the cost of a droplet.
Probably matters a lot, too, if you are already experienced with that technology or if this is all something you'd be learning new, right?
It also means you could get into some of this stuff for a relatively low price and start experimenting with it. So it could be worth a read just for that, too.
I'll be curious to see what the audience thinks about that particular debate.
And there's a fancy tool you found this week.
KubeDirector is an open source project designed to make it easy to run those complex, stateful applications that have proved to be oh so difficult for Kubernetes. In particular, it gives you the ability to run non-cloud native stateful applications, which, there's still a lot of those out there, Chris.
Yeah.
Without modifying the code.
Say what?
In other words, it's really just not necessary. You don't have to decompose these to fit into a microservices stateless design pattern, which maybe you might want to, but that all takes time. If you're already moving to Kubernetes and you just want to move this right on over, maybe KubeDirector is right for you. Also, something I missed, this is a little bit of an older blog post from Josh Reddeck, but it's by far the best rundown of getting a Kubernetes on bare metal installation set up. All the little details you might have to know. How do you get storage to actually work and what are your options? Go check it out if you're not just running Kubernetes on the cloud or you want to have an idea of can it work on bare metal?
Yeah, if you're sick of buzzwords and you want the nitty details of what you actually do to get it set up, that's the link to read. That's a good resource. And then last but not least, speaking of different ways to play with this stuff, DigitalOcean is introducing Kubernetes in limited availability on their systems. I like this a lot because it promises this future where you can manage local infrastructure, DigitalOcean infrastructure, Google Cloud infrastructure, all with Kubernetes in one spot. It seems like the perfect promise of truly globally available systems that you can deploy up on demand as you need them across multiple cloud providers.
Right. They all have the same APIs and the same abstractions, and they all take the same sort of runtime, right? You make this container image and you ship it up there, and away you go.
Kubernetes is a massive, batteries included kind of topic, but we wanted to spend the last couple of weeks touching on it for you because it's something that this show needs to talk about, and we want the audience to have a general understanding, and we feel like these can be a couple of foundational episodes, so when we talk about this stuff in the future, hopefully you'll be right there along with us. And for a lot of you, you probably know a heck of a lot more than we do, and we'd love to hear from you, so don't be shy. Hit that contact page and share your wisdom. We'd love to read it.
And that brings us to the end of this week's program.
Thanks so much for tuning in, and we will see you
next week.